Hello. Why does this do this? Well, they're magnets, right? And right now, the same side of each magnet is facing each other, so they push apart. We say they repel. Now, you may have heard that opposites attract.
Opposites attract. Opposites attract. Positive, negative, boom. There it is right there, simple. Opposites attract.
Well, it's true. Watch. See that? They pull together. They attract.
Magnets are surrounded by magnetic field lines or magnetic lines of force. These lines just show us where the effects of the magnetism are found. Notice where the lines are concentrated or close together. That's at the poles. If you look at the North Pole and the South Pole, you can see a lot of lines come together. This is why magnets are strongest at the poles. Look in the middle. There's not really even a line right there or right there. So magnets are weakest in the middle. So a little stronger here where the lines are, but definitely strongest at the north end and the south end. Now the Earth has a giant magnet in it because of the Earth's core, which is melted or molten metal, mostly iron and nickel. So look at the magnetic field lines that surround the Earth. Kind of like the other bar magnet that we saw, you can see that it's strongest at the poles, the North and South Pole. And notice that the Earth isn't quite straight. It's a little bit tilted on its axis. Here are the magnetic field lines of a normal bar magnet. Let's look at what happens when we have opposites. So we have a north and a south. Opposites would do what? They would attract. Look at the field lines. See how they want to join up? Notice how the lines from north and south are coming together. So they're going to attract, and those field lines are just showing the attraction that would pull these two magnets together. Here's what happens when you put like poles together, either two norths or two souths. Look at the field lines. Do they want to go together? No. Each line, instead of going together like they did here, is bending away. So they're trying to repel each other. Those lines do not want to touch. And you would see the same thing if you put two south poles together. If they're the same pole, those lines are going to try to push away from each other. But if they're opposite poles, like the middle picture, you can see those field lines attracting, pulling them together.
This train floats over its rails on a magnetic field. It's floating on magnetism, so there's no friction to slow it down. So it goes fast.